Open your books to page 239. We are starting a new lesson and a new activity. Lesson 16.1, writing and graphing inequalities in two variables. So our first learning target is to write linear inequalities in two variables. So usually we're using x and y. And read and interpret the graph of the solutions of a linear inequality in two variables. So we have a real-life example here. Axel and Anisa pay for and share memory storage at a remote internet site. Their plan allows them to upload 250 terabytes or less of data each month. Let X represent the number of terabytes that Axel uploads in a month. So that'll be easy to remember because there's an X in Axel. And let Y represent the number of terabytes Anisa uploads in a month. Question 1. Look at the data for 4 months below. Determine if Axel and Anisa stayed within the limits of their monthly plan. So in the first row, we have 50 terabytes and 120 terabytes. If we add these two things together, the total is 170. And is 170 less than or equal to 250? Is that within the plan? Yes. Go ahead and finish filling in this table. $135 plus 100, that's 235. So yes, that's within their plan. 100 plus 150 is 250. So yes, that's within their plan. 162 plus 128 is 290. So that's outside their plan. Question 2, write an inequality that models the plan's restriction on uploading. So we're going to use an X for Axel and a Y for Anisa. And I'm going to add these two things together. And what is the total amount? 250, that's the restriction. Could we be exactly equal to that? Could I be greater than that? Could I be less than 250? So Axel and Anisa, X plus Y, could be less than or equal to 250. So that is our inequality sign. Less than or equal to 250. So no longer equations or equal signs. Question 3, if Axel uploads 100 terabytes, write an inequality that shows how many terabytes Anisa can upload. So what was the total? 250. And Axel uploads 100, so what's left? 150. But we're writing an inequality for Anisa. Which variable do we use for Anisa? We use a Y, so Y, and then the limit is 150. Could we be exactly equal to that? Yes. Could we be less than that? Yes, but not greater. So Y, Anisa, has to be less than or equal to 150. So go ahead and try question 4. Anisa uploads 75 terabytes. Write an inequality that shows how many terabytes Axel can upload. Axel has an X up to 175 left. We could be exactly equal to that, or it could be less than. The graph below represents the possible values for the number of terabytes that Axel and Anisa can upload. An ordered pair, X, Y, represents the number of terabytes that Axel and Anisa upload. For example, if we have the coordinates 100, 75, this is X and this is Y, that means Axel, X, uploaded 100 terabytes and Anisa, Y, uploaded 75 terabytes of data. Okay, so if I'm looking at this graph, let's just label this with Axel and Anisa. In question 5, I know these boxes are really tiny, so good thing you have this in your book in front of you. But we're going to graph each ordered pair and then determine if it allows Axel and Anisa to remain within their plan and explain your answer. So for letter A, it's 250. So over to 200 on your X, up to 50 on your Y. Okay, so if I plot that point, oh wait, let's look at what each little teeny box is. 30 divided by 3 is 10, so each little box is 10 if that helps you. So 200 is here, up to 50 would be right there. And I'm looking to see, is this on the edge of my shaded region or inside my shaded region? And this answer would be yes. Why? Because it's in my shaded region, so it's within the plan, and you can write that out. Yes, it's in the shaded region, so it's within your plan. Or remember what you did in the table, we added them together. So 200 plus 50, yep, 250, it works. Okay, so go ahead and graph B, C, D, and E. Pause the video if you need to. Letter B is no, because the point is not in our shaded region. Or when I add 150 and 150, we get 300, and that's above 250. C is yes, it's right on the edge, the border. The point is in the shaded region, it's within the plan. 225 plus 25 is 250, so it works. D is yes, it's obviously within our shaded region. It's 140, so it works. That's less than 250. E is no, it's not in my blue shaded area. It's outside in the white. And when I add those two things together, I get 320, which is over or outside our 250 mark. So this graph right here is an example of a linear inequality using two variables, x and y. All of the points within this blue shaded area are the solutions to the inequality. They're the answers. Okay? Linear here just means it's a straight line. I'm not sure if I'm jumping ahead, but usually there is going to be a line here, and what we call this is we call this a boundary line. And we're going to talk about whether it's solid or dotted or solid or dashed. And things on the boundary line, if it's solid, those are within our solution region. Okay? So a solution region means that those ordered pairs make the inequality true. When I plug them in, I get a true statement. So like one of the ordered pairs that we had was 20 and 120. So when I plug that into my inequality, 20 plus 120 makes this inequality a true statement because 140 is less than or equal to 250. Yes, that's true. So this point was in our shaded area. It worked. Okay, if it's outside our shaded area when we plug it in, we get a false statement. Check your understanding box on page 241. Question 6. Axel and Anisa decide to change to a 350 terabyte plan. How would our graph change? I want you to jot something down for question 6. How would you think the graph would change? Axel and Anisa are allowed more terabytes. So what that means is that my shaded area or my shaded region is going to be larger or bigger because if I go back to this graph, I forgot earlier to talk about our x and y intercepts, but if I'm looking here, my x-intercept right here for Axel is 250. Okay, if she's using all of the data, Anisa doesn't get to use any. My y-intercept up here is also 250. So if Anisa's using all the data, Axel doesn't get to use any. Well, now if we're increasing that to 350, my x and y intercepts are now going to be at 350. Thus, my shaded region is going to be much larger than before. And if this was to scale, it would be much bigger. So your x and y intercepts are now at 350. So that also changes. Oh, and I just did question 7 for you. Graph the inequality. So, just take this guy. Oh, maybe if I can move it all at once together. Move it down. I got so excited talking about the x and y intercepts that I graphed it. It doesn't have to be fancy. You can just put it somewhere in the My Notes section of your book because there are graph paper portions. It doesn't have to be fancy. X represents the number of terabytes Axel can upload again. So this is Axel. This is Anisa. And I graphed that for you. So question 8, obviously we could spend time graphing these, but our graph in the My Notes section of our book is not going to be perfect. So instead of plotting all of these ordered pairs to see if they work or not, what else could we do? We could just add them together, right? If I was thinking about writing an inequality, and I'm just going to put it in this space right here because I have room, Axel plus Anisa, they have a total of 350. They could be exactly equal to that, but they also have to be anything less than that. Okay, so if we add these two things together, 200 is my x, plus 50 is 250. Is that less than 350? Yes, so this works. Okay, 150 plus 150 is 300. Is that less than or equal to 350? Yes, it's a true statement, so it works. So go ahead and pause the video, and I want you to answer C through F. Do they work? Question C, is it less than or equal to 350? Nope, doesn't work. D, yes, it works. E, no, it doesn't work. F, when we add these two things together, what do we get? We get 350, but let's think, this is a story problem. Okay, and if I look at my graph, either this new graph that I roughly sketched, or if I go back here, do we have anything graphed in the negatives? No, think about sharing a phone plan with maybe your family members. Could I say like, hey brother, I'm going to use -10 on our data plan this month so you can have extra amount of data on your phone. It doesn't work that way, right? Because this is a real life story problem, we can't use negative data. So this is no, doesn't work. It's not on our graph. Notice how when I was shading, I stopped at my X and Y axes. I didn't keep going down into the negatives or over left into the negatives. Okay? So for question 9, it says explain how to decide whether an ordered pair is a solution to a linear inequality. Well, I would take that ordered pair and I would substitute the values of the coordinates, so whatever your x and y's are, into the inequality. If the result is true, or if it's a true statement, the point is a solution. If the result is false, then no, it is not a solution.